Good morning, students. It is Wednesday, and we are getting ready to do math. Okay, hopefully you have just gotten done with your Power Up 98. You're doing your transition chants, checking the mental math, checking your problem solving, making sure you fully understand that. We're moving into lesson 98. Pretty fun, easy concept, geometric solids. Okay, so here we go. Okay. I'm going to be kind of basic on this one and be reading from the book, and then I got some cool manipulatives that we're going to play with to show you. So, two-dimensional figures such as triangles, rectangles, and circles are flat shapes that cover an area but do not take up space. They have length and width, but no depth. Objects that take up space are things such as cars, basketballs, desks, and houses. People also take up space. Geometric solids, geometric shapes that take up space are called geometric solids. Solids have 3 dimensions. The chart below shows the names of some geometric solids. The first one, as you can see, is, cubes. Okay, so check this out. We got these magnetic shapes. There's a cube, okay? And it's a rectangular prism as well, okay? Next one, rectangular prism, then triangular prism. So rectangular prism, triangular prism. So we got those over here too, okay? So here we have a rectangular prism, okay? Kind of interesting to think about that, okay? And then a triangular prism. And you're wondering, okay, all of those, what is a prism? Well, let's read this cool little thing here that'll show you if you were here. A prism is any solid with parallel bases that are congruent polygons and faces that are parallel. So what does that mean? Okay, that means this face and this face are parallel. They have parallel bases. What does that mean on the triangular prism? That's got the triangle here, and when you set it up, that face and the bottom face, well, maybe easier this way. This face and this face here are parallel. Remember parallel, the word parallel, the 2 L's make it parallel, okay? Rectangular prism has its parallel there, and man, lots of ways there and there, okay? So that's essentially what a prism is. A prism is named for the shape of its bases. For example, a triangular prism has bases that are triangles, okay? So that's why this is the bases. The triangle and the triangle are the bases. We think about the base being the bottom, okay? So triangular bases, okay? Those are prisms. Then we get pyramid, okay? A pyramid, that's kind of fun, okay? And we'll be constructing these in a future lesson, okay? But if we look at this, woohoo! All of a sudden we got that cool looking shape can suddenly come up to all of these are called faces, coming together, and I have a square and then 4 triangle faces, okay? So that's a pyramid. Then a cylinder, all right, my coffee cup, cylinder, circle base, okay? So there we go. Sphere, I think you guys can all picture a basketball or a baseball. A cone, I made one out of a piece of paper. I don't have any shapes like that, okay? That's what a cone looks like. This is what it would look like if I put it on my head. Ta-da! All right, okay, so as we turn the page here, example 1, name each shape. That's a sphere, a cube, and a cone. We just learned all those. Okay, now this is some new information here. Okay, what is the shape of a soup can? Well, it's a cylinder, right? A soup can would look kind of like my coffee cup. That was the cylinder, okay? A soup can was a cylinder. A flat surface of a solid is called a face, okay? So this is the face, okay? So if you could imagine my coffee cup, here's my flat surface. That's my face, okay? This right here would be a face. Now imagine that that was all filled in and solid. Okay, my square. Okay, if I take one, that's a face. Okay, and you got to imagine that that's completely filled in and solid. Okay, that's a face. Okay, so those are the faces. Okay, so here's a face, here's a face, here's a face, here's a face. Okay, now we got a vertex. A vertex is right at that point, right where, and this is an edge. Okay, so, and this is an edge. Okay, so where this edge and this edge meet, the points, is called a vertex. Right here would be the vertex where this edge and this edge meet. Okay, so in this shape, right here would be a vertex, right where the edges meet. This edge meets this edge, vertex. Right here's another vertex, here's another vertex, here's another vertex. Okay, so, and Mr. Mondo wrote in his book, you guys aren't allowed to do that, remember? Okay, look at that, but I did a pencil, I can erase it. Woo! Okay, now a circular cylinder has one curved surface and two flat circular surfaces. A cone has one curved surface and one flat circular surface. The pointed end is called its apex. Oh man, it fell off my head. Seasick video. So here's the apex. Okay, that's what we just read. A sphere has no flat surfaces. That'd be like a ball. Okay, so I do have a sphere. You don't even need to imagine it. Check it out. Basketball, hoop, shooting. Horrible shot. Okay, that's a sphere. No flat surfaces. Okay, don't you wish we could shoot those points? I sure do. Okay, so now we go. How many faces does a box have? How many vertices? Okay, vertices means the vertexes, but plural is vertices. How many edges does a box have? Okay, so we look at that. Okay, so 6 faces. Okay, so here we go. I'm gonna disassemble this one. Okay. Sorry, staring down for 2 seconds. Okay, so we look at that. 6 faces. Okay, 1, 2, 3, 4, 5, 6. Okay, and those all come together. Okay, so 6 faces. Oh, you guys are 6 faces there. I bet that was sideways video here. Okay, so 1, 2, 3, 4, 5, and the bottom one is 6. Okay, so you guys could see that when it was flat. Okay, I'll take that apart again here real quick. I didn't think about the fact that when I turned my phone, the video is all messed up. Okay, 6 faces. 1, 2, 3, 4, 5, 6. They all come together, right? And you suddenly end up with 6 faces. Okay, and then 8 vertices. Okay, 8 vertices. 4 are on the top, 4 on the bottom. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. Okay, and it's easier to see it with that. But here, you can't see all 8, right? So there's 1, 2, 3, 4, 5, 6, 7, and this one back here would be hiding. Right there would be 8. Okay, so that gets to be a little challenging unless you got that. Okay, which is, now we're on edges. Okay, 12 edges, 4 on the top, 4 on the bottom, and 4 running from top to bottom. Okay, so edges, 1, 2, 3, 4, right? Bottom, 5, 6, 7, 8. And then the one's going vertical, 9, 10, 11, 12. And that's a lot easier to see. If you guys can find like a cereal box or something like that, you'll have a lot easier time being able to see all the edges, all the faces, all the vertices, rather than just trying to see your picture when you have something 3-dimensional to work with. All right, so that's the end of the new concept. I hope you enjoyed. And now you can do the lesson practice and check your lesson practice with the answer key before you start the written practice. And make sure you fully understand it before you start the new concept or the lesson itself, written practice. Have a great day, guys. Enjoy doing your math. I miss you. Wish we were here and I could be working with you in person. But we'll talk to you tomorrow for lesson 99 and 100. We're going to do both together, new concepts. All right. Later, guys.